go. How? How? Why is this what else? What? That's on the stack, I think. All fives. Or is it the other way around? It's the same address. What the hell? here. Difficult stuff. I have a bug that I just can't find. Just can't find it. Hours and hours and hours. There's something to do with forking. I wish I could. What again? This stuff is still the same here. Hello, Sam. Bang. That exactly exactly what I shouldn't do that. I wish I could continue debugging the forked child process. Completely useless shit. At least I have threads now. There's something. Before I didn't even have threads. Definitely making progress soon. So let's switch to the running thread. Probably the event loop thread here. It isn't doing anything. It's waiting an epoll. I think I can continue here. Let's see, hold a minute. It's in here. That is going to call the out. Maybe my breakpoints still work. I'm not sure. Let's put a breakpoint here. Breakpoint 177. And then continue. Oh, it's already there. Oh, that's good. So now step. Not continue. Finish. Step. Finish. Step. finish, step, finish, step, finish, step, start. Also start is not interesting. Finish, step, finish, step, finish. Step, next, checking L off, okay, current. Can I print this stuff? What is error text here? Interrupted system call. Oh, that's why we continued. So okay, so this is debug output. I'm writing debug output now, as in debug output. It's a macro, and that it should also be flushing. So everything that is being written should be immediately be flushed. And I'm writing to a standard F stream now. So no, I'm not. The question is the question is why do I not see this being written to the output file? So it should be logging to this file. So that was the last thing that was written. It should be writing to this file and it should flush it. So I should see it. But that's not happening. And since I have absolutely no clue why not, I just have to, debug everything down to the last single bit. For example, I think what happens here is we write, but we write to an O stream. This is an O stream. Let's see what is the type of the thing. Sorry, it's an output string buffer. It's a string buffer. String stream. Whatever. It's a string stream. And which is also an O stream, but I should be able to cast it back, say, to the string stream that it is. The thing has a virtual table, I guess. So you should see what it is if you just print it. Yeah, it's a buffer stream. There's a V table is for this object. Well, that is the actual object. But there's an offset of 24 here. I'm not sure how to cast that. So this address is also completely different than that one. Lots of zeros though. looks like the only thing we really have is a string buf pointer. This object. Maybe it doesn't make much sense actually to look at this. I should just wait until it is written to the real O string. And then we can see how many characters it writes. That's good enough. And even what it is writing. Okay, this string buf has a beginning and a current and an end. And the current points to -1 something. There could be junk in it, of course. Is it not like... I think this is where it starts. There should be an unfinished. Yeah, this is junk. And the junk is here. So this is what was written so far, which is correct because we called equal p8 and then equals and space, and then we don't know what it returns. But now it returned, and I'm writing that. I could go up list. So we just returned from equal weight. And the return value is this, is -1, because we have an error, and the error is, what was it, interrupted system call. So now we're going to write, including the error, -1, and then colon, I think, and then interrupted system call. That's what this thing does. And that should append it after this point. So it writes the -1 should already be written. Because yeah, maybe the curve was not updated yet. Anyway, we do a next here. Then now it has been did write it. The error number as a string and error text. So the buffer content should have been updated. Let's see if we can see that. Yeah, so now it looks like it should be. This part changed. So it does write, but this is just to an string stream, output string stream. And then, since we are in finish, it's also going to write it to. I think it's just all the way here. Everything. Cur is still -1. I think this is being bumped later. Okay, frame 0. It has been written. No new line. Well, yes, we want to write new lines. Color. Don't know about the color. Color off. Okay, I think it's just this part here. Turning color off and then write a new. So we should be here now, I think. Or actually, I think this looks like junk. This was the previous one. We had something like 7720 parentheses close and then turn color off, and then a new line. And now it's here, which is very unclear because this one points still at the -1. But I think it's going to continue writing now after this parenthesis close. And then we're going to write the color off and then a new line. So this writes the caller off, and then we write a new line. I can print that again. Yeah, see, so it is again that it was running here. So now this is everything that has been written to my O stream. Then now the current mask is are the flags, and that did include the, well, that's just these finish. So I think just this actually. But there are flags. This is the debug channel, and these are flags. There's a conditional error flag. So since the NFDS equals -1, this equals error condition flag, control flag, I think actually. So yeah, this should be equal to the error control flag, aka non-zero. Doesn't look like a single bit though. What the hell? Lots of bits. Huh? What? Why would I have 4 flags set? Well, I don't care. It's non-zero. Is it a core dump or fatal? No, it's just a normal finish. Do we must it wait? No. So now it's going to write, and we are. This is the real buffer. I'm still not sure what this is. Oh no, the other way around. This is the buffer that we have this text in, and this is the target OS that we're going to write to, and it must flush. So I should step into this, and then wait until, well, check that it's returning true, of course, and then wait until we enter the write to. I'm just going to do steps, I guess, until we actually step into something here. So I wanted to flush, so this thing should be larger than 0. I think it used to be larger than 0. I think that there is a problem here as well, because this is 0. Yeah, so it's not flushing like this. But why? And then I turned flushing on by just changing the memory value to something to 1. And then it still didn't write. It's one bug on top of another. There's a completely different address. I mean, I had the 555758140, which I pasted in the chat. That contains 1. Why is this suddenly a completely different address? That is maybe a different address because it's a different thread. Is that per thread? Oh, so I don't have flushing on. Oh, I don't have flushing on for all threads. Oh, wait a minute. That would explain a few things. However, if I turn this on, so you can do set and then just set it to 1, so we have to get this to something non-zero. Then now it's going to return true because I made this 1. It's larger than 0. Returns true. And that true is then going to be passed to. So this is one bug. Every new thread should inherit from the main thread or from the thread that is spawning the new thread. This flag. But even if I set it to 1, it's still not writing debug output. So let's continue debugging this. Now I want to enter that right too. There we are. And do flush is now true. Okay, just continue stepping. Next. This gets the size. This is the buffer. Huh? We're calling this is a member function on that buffer. So the current object is the buffer. Let's just examine that again. Yeah, and it is in full here now as a string, basic string buff. Here's the text: color on, event loop thread system equal wait -1, interrupt meaning interrupt system call, color off, new line. That's what we're going to write. And that has a size of, if I count correctly, 1, 2, 3. Wait a minute, yeah, escape. So there's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 21, 27, 8, 9, 30, 31, 32, 33, 34, 35, 36. Why am I counting? It doesn't really matter. I think. So we do next. Is this now 81? 40. Bah, what? Oh, it is 40 because this was already written. We just added that part. I can count that again because now I want to know. 1, 2, 3, 4, 5, 6. 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27, 28, 29, 30, 31, 32, 33, 34, 35, 36, 37, 38, 39, 40. Exactly. So this is what we just added. Correct. Yeah, those are 40 characters, and that's what we're going to write now. Get n. What the hell does that do again? So it's string get to return something. Does it look like I'm assigning that to anything? Is it, oh, maybe it's going to write to message buff. This looked like uninitialized stuff, so I do next. Yeah, now message buff has assigned the stuff that we must add. So it did read it from one buffer into another one, into message buff. I'm not sure what message buff is though. Message buff type. It's a local thing. I think this is the stack. Right, so what is next? Lock the O string. I did set the mutex, so this should call lock on the I don't have to debug into that. I think it just locks the mutex. Code lock should be true. Then the debug object itself is locked. And now we get the locked O string. I have to check that this is indeed the file that I expect to be writing to, and that it is has a good bit, and that it is, yeah, I don't know, because it's not working. So where is this going wrong? I mean, what is OS? What? Okay, well, that. Now we know what is going wrong. It is writing to standard out instead of to the. And it's nice that it tells me what it is. This pointer. Okay, yeah, okay, yeah. So we don't have debug output because it is writing in the end to standard out instead of to my file. What the heck? Why? How? This is the second problem. So the first problem is mysteriously this thread, because we are now inside the non-main thread. The main thread is 1. This thread doesn't have the always flush bit set, and it's writing to the wrong O string. So where exactly do we get this OS from? So continuing to debug this it makes no sense, because the whatever it's writing to is already wrong. Let me go to the source code. Line 302 of what? Where are we? Of this. Well, let's look here. Where does that OS come from? OS was passed to the right 2. Okay, so you can go up. It's the target OS, and that is this file. Same file. And what is target OS then? The question is now, why is that not my F stream? Target OS here. Target OS is the real OS, the debug object real OS. where the debug object was passed here. So if we go up until we are inside finish, and then I can print this to see that that is also standard cout. We are in finish, so I can print this. That is cout, indeed. And then the debug object is a debug class type thingy with the real OS equal to that, which was passed to the finish. So we go up. That is being passed here, which should be just a default debug output, debug object, I mean. So now the question is, where did that come from? I think, well, this is a macro. I have to find the macro, so we can go here, or rather, go there. Quit VI. This macro, where is that defined? The out. It's defined as libc out, etc. And this is the debug object. So it's just hard coded. Thus, that should be something that has standard cout as real OS, which is correct. However, is this object a thread-specific thing or something? I mean, it's a global, but maybe it's we have a different debug object per thread. I really don't think so, because I did call a set OStream on that object. Did I not? I'm starting to wonder now, but let's first check that it is indeed a normal global object. So where's this defined? In here. I guess there. Well, that looks totally like it is a normal object. Class type, default object. It's a bit too much indented for a global object though. Right to, wait a minute, confused. No, this is, no, it's not. What? Why is this so indented so much? Well, yeah, you can't have a namespace inside a class. Well, oh, well, I wrote this I don't know, 25 years ago. Apparently I did an indentation for namespaces. So I guess this indentation is for a namespace. Which is, yeah, I have not been doing that for a long time. And it's a class. It's a class anyway. How is that possible? It's not possible, of course. Class ends. Class already ends there. Must be a namespace. There's a private namespace. That namespace is libcwd. Yep, that's 2000 lines. And then here we have an indentation of 4 spaces, which is also something I totally never do anymore. So we are in namesize libcwd at that point. Yeah, so it's totally a normal global then, global object. It should also be defined in the header, of course, somewhere. Yeah. Well then, that is very strange, because I would think that I'm changing that, the real OS, in my code. Grep set ostream. It is done after we go to the background, so after calling daemon. Oh, wait a minute, this is wrong. It is wrong in so many ways. Dang. Yeah, well, still, I mean, I would, crash I would have understood, but this is a member of the socket tap daemon application object, which is destroyed because it splits up here. Yeah, no, we go to the background here and then we return and then that application object is destroyed. Isn't it? Well, actually it shouldn't be. I think it is though. So I'm writing to an OStream that of a file that was closed again already, because this is automatically closed when the application is destructed. So we should not destruct the application object because, well, the log file lives there, or make the log file a standard unique pointer or something like that. Or an, well, no, I mean, well, something that survives longer anyway. At the very least, a log file. At least we have a few leads now. I think I can leave it debugger. Definitely a lot of leads here. To the main application constructs this. Yeah, well, that is destructed here, but we are hanging here, are we not? However, we also went to the background, which is a fork. So there is two applications, two processes with different PIDs running here, using the same, having the same object. Which is okay, but if then one of them destructs this, I think the file descriptor, oh my god, possibility. We open the log file, then we go to the background. No, we don't, sorry. No, we don't. But this is the main thread construct this object. Then we go to the background, so then we have two processes, and one process just didn't open the file. And that one exits, which is weird enough, because I think both processes come here. I have to exit the other one. Is it not automatically exit? Does it not automatically exit? Probably does. It's a bit unclear what daemon is doing. So look it up. The daemon function is for programs wishing to detach themselves from the controlling terminal and run in the background as system daemons. Okay, here it is. The parent calls exit, so that further errors are seen by the child only. On success, daemon returns 0. If an error occurs, daemon returns -1 and sets error number to any of the errors specified for the fork. Set SID. But I think an underscore exit is a very hard exit. That wouldn't run any destructors or anything. That process just evaporates. Exit terminates the calling process immediately. Any open file descriptors belonging to the process are closed. But it's per process, right? So we inherited them and then we close them. Does that mean that all file descriptors are closed? I don't think so. Any children of the process are inherited by init or by the nearest subreaper process as defined through the use of PRCTL. Process parent is sent as sick child signal. Maybe we should wait for that. I don't think I'm using daemon correctly. This last forced alinea is so annoying. Just never read it. I'm stopping reading it. The rest was good. Okay, so daemon more or less does the most intuitive thing. We just switch to the background, no problems. Okay, I'm an idiot, I think. I'm definitely an idiot. An idiot. Socket tab daemon is constructed. First, first the base class is constructed. Then the members. And then we call initialize, which processes the stuff. In other words, this is never set if we get here. By the time we get here, is it even going to the background at all? What? Now I'm so confused. Let's forward this. So this is the constructor, but first application is constructed. And that constructs a thread pool. Okay, I'm constructing a thread pool with no threads, so that's actually okay. No threads are being created. And this is unique pointer. Also, this is not created, I think, or is it? No, that should be created also from initialize. Yep, by the time initialize is called, there is no event loop yet. So maybe it does work then. So no thread has been created, and then we call the initialize here, and then can I create a new queue without having threads? I think so. That doesn't make sense. I mean, now I don't have any thread at all. I don't need a queue here. It just doesn't make any sense to put that here. But I don't think that is the problem. So here then we are processing all the command line arguments. It might be none. Well, the log file is processed. Doesn't do much. And then we call we want to do it from VI. And then we call this function, which is a virtual function, which then calls this function actually of the derived class. And then foreground was not set, so now go to background is being called. And at that point, The feeling it's slipping away again. Turn all debug output off. Demonize, and that just changes the parent PID. Well, the rest is just that the other one is gone. And then this is not empty, so we open the log file. Turn debug output on again and exit, go to background. And then exit command line parameters. And now we are running in the background. Create the queue. Now we create the threads for in the thread pool. And the event loop is created. Another thread. And then we return from the initialize. So now we are here, and now we return from the constructor. So the moment we come here, we are running in the background, and we have all the threads in the current process, in the background process. And then we have a problem, because this was already called. Or not. Shouldn't that just survive, I ask? I wonder. I think it should just survive. But we saw that it didn't, yes? So we might well concentrate on that bug first. So after we run in the background, oh boy, I have to pause that. Yeah, so we don't have that. Okay, let's make that. I have an is on as well. You have an is on here. Thought that was also just a user function. Don't get this at all. Oh, maybe it's mod. Mm. did not assert. It's an impossible problem. I really don't understand it. The guy is negated. I know I want to see it assert because I'm starting to doubt if assert is even working. If you get what I mean. I know, ridiculous, but still. Of course it's not asserting. It's in the background. We will never know if it is. Okay, let's do the following then. Kill all socket tab. There were no processes because it asserted, unfortunately. We have the PS tip. Nothing is running. So it must have asserted. So it changes back. That means that if it, now it is running, then it did not. No, it did not assert. Which is annoying because, well, the warning is not good probably. So now this is not even printed. Nowhere. Why is it still in attached GDB again? Oh, because of this. And that happened because you did change the directory, I think. So as every time in the debugger this was 0. And now it's 1. Can someone explain that? It's a Heisenberg. If you look at it, it's different. Maya, I want to know the address of this thing then. That is on the heap. It's at least good. Before it was mysteriously on the stack. In case it ever changes. And then this is not writing to debug output. Info threads. This is the main thread, yes. Why would the main thread not be able to write to my file? Did we already go to the file? Yeah, we did. Okay, so I should have an open file. Let's see. Things called application thing. Application. That's a lot of stuff. A little bit too much. Oh, that's even brilliant. I wanted to print. The log file is an incomplete type. Thank you very good, debugger. Super helpful. Okay. Yeah, this. The address of my debug object is this. And I want to know why it is that, not what I want. You did go to the background here. Entering background rather. Wait a minute. Frame. Oh, what? No, wait a minute. At this point, we did already go to the background, yeah. No. Huh, what? Why? So hit breakpoint. And why is that? This makes no sense. This makes no sense. Oh, I'm not attaching here. Okay, we just went to the background and there are no threads, which is good. And here I set a different O string. So at this point, libcwd, libcwdo has obviously a real OS of standard shout. And the address of my object is the same. No, it's not the same. It changed. Set OStream. Real OS is not this. So is that going to be changed back, or do we just have a completely different debug object suddenly somewhere? That worked. Creating threads. Ah. Ah. Aha. So it is changed back. It is changed back in change the number of threads too. Wow. Finally, we have it. We have something anyway. This is like bug number 8 or something. I lost count, but okay. Oh, yeah, we even have a backtrace. It is happening from the initialization of a thread. Yeah, like no way. Really? Why would that call set ostream? Because that's global. That's really bad. Maybe that's only doing that for the very first thread, which I was deliberately skipping. Let's see. Up. This is inside. Set ostream. Up. That's pretty rude. And utter bug, if you ask me. Isn't it? Overriding it for every thread makes no sense. I mean, this looks like it thinks that the ostream is per thread, which obviously is not. That should not be done here if it is a thread. Where are we? What the hell is this? Copy. Let's go to debugging library. Init thread. Yeah, init thread should not be doing that. My God, what a horrible bug. Yeah, I don't get it. I'm gonna delete this. No work to do. I just changed the file, dude. Changed the wrong file. Oh, that's CWDS. It's not even this. Oh yeah. Never mind. Sorry. So it's a bug in CWDS then. But it's a little bit less worse, less bad, but still pretty damn bad. Really bad. Really bad. There we are. We have debug to the log file. Ooh. Well, yeah. Tough one. Kind of shocking though. Full debug output. All the way until waiting in EPOL for something that we can listen on, and if now we run this, we will see that there is more debug output. And there's Call 911. I'm getting a heart attack. What the in the actual no. There's no end to this bug. It's how? Why did I deserve this? Oh, this is impossible. This is absolutely impossible. I would say that we are still hanging here. So it never returned, aka this is never connected. I mean, come on. No way. If we just send this thing a signal, then we return from here, right? Just do that. So let's say where's my PS? Yeah. Kill sick int. It's no longer running. That's annoying. No debug output. There is really no more debug output. I think these two are not doing anything. Threadpulse is not being used. Let me check that. Yeah, I don't know. It's not doing anything. I mean, it's doing something, or it doesn't belong to the process. It's just a thread waiting in the thread pool for something to do. Same for the other one, of course. So the only thing that that should be doing something is this thread. Also waiting on condition wait. That is it a gate? No. Oh, one. Sorry, doesn't count it. Sorry, I have to do 2. Thread 2 is waiting in equal p wait. Yep. Okay. Why is everything optimized out? This bloody debugger is so unusable. That's a scary amount of zeros. Well, okay. Well, probably... what is Equal P8 even doing? It should be waiting for something. File descriptor 34. I think that was my listen socket. Can we figure out? Didn't get PID, is it doing something? Stupid debugger. So this is my PID. Let's proc PID. Can do the exec. That is the socket tab daemon. And we can look at the file descriptors. There is a socket, and that socket is 35. Nnon inode event pool. Event pool. Maybe I'm not understanding anymore how ePOL works. Logout is still open. I think we really never returned from there. ChatGPT, help me. Should it not already have flushed this? That unit has a flush. So that should already be visible. Yes, it is. It was visible. Temp logout. Why is that a 0? Thought it didn't return yet. System enable CTL. Oops. Wait. That's not what it is printing here. It's no equal weight here. So that was not flushed. Or the debug output stopped again after this point. Oh, here it is actually. It is of course this thread. Yeah, never mind. And it's not printing what it is passing. Kind of stupid. People create 34. Okay, 34 is the EPOL socket. Why is it calling it twice? 3 times even. Created 3 times. Sick mask. 34 is a signal. Nobody gets it. What is going on? The same debug output was printed 3 times. And we have 3 threads. Suspicious. Yeah, the 35 is the socket, right? This is the socket. Where is my 35 being returned? Nowhere. Well, 35 is the socket. We said sock ops bind everything. Oh, here it is. So it's created. That's a listen socket. Call listen on it. Call listen on it. Now it's a listen socket. 35. Then 35 is added to EPOL descriptor 34, which means that if I connect to that socket, aka this socket, then 34, the EPOL socket, should get an event, and therefore this should return. I'm going to drag EPOL in it. There's people should go to bed. Drag ChatGPT into it, although you know it's not an AI. But maybe it gives me a new idea. I have a problem that I can't figure out. One thread writes the following: debug output. AKA .34 is an EPOL file descriptor or something. Figure it out. Another thread writes after the above aka from script 35 is a Unix listen socket. And was added to 34. If now in a different terminal I connect to this Unix socket, that seems to work. Again connect, I don't get an error, and right. But it seems that the thread that is waiting in can't find it. Yeah, people wait. Is that a system call? Equal p-weight. So now it did return. Not because I connected, but it did return. So at the very least, I want to see a debug output now, right? Yeah, and we did. Okay. So what is it called? Inter was received. During getting that info with GDB. The function did return. Printed more debug output and re-entered equal p-weight. Yeah, well, I don't want to confuse it. It should have been flushed as well, I guess. And it isn't. Get bloody returns. You see, the only thing you have to do is spend 20 minutes typing to ChatGPT, and then it does work. Why is it suddenly working? I'm so clueless here. No, might as well delete everything I just typed. Nope, it just works. But we don't have debug output anymore. No. Oh. No. I didn't return. Okay, what? No, no, it did return. Oh, that's interesting. it is no longer in. Oh, what? Producer access, wait. Oh, there's a deadlock. Oh, so something did change. It is no longer in the wait function, the pull wait function. Why did I forget the name of that function? The equal p wait. So we are hanging info threads. Up. Codex pthread condition wait, condition variable wait on a lock. But I wonder which lock that is. Buffer full, producer access wait, AI object queue. It's a thread pool thing. But this was also not printed. So why was this also not printed? Maybe, I don't know, maybe it's part of the debug process to begin with or something. It means that maybe debug output is turned off now. Let's go up. Mint emin q access wait until q access notifier 1 is called. Event loop threads. Q full. Q capacity. Zero. Oh, my queue capacity is 0. Yep. Yeah, we do. The queue is 0, so we cannot add anything to the queue. That's interesting. Where are we trying to add something to a queue? What function is this even? Event loop thread e-main. I don't know what is this. Let's have a look. Queue the events for processing by the thread pool. What is looking suspiciously much like the thread pool itself, like duplicated code? Not entirely. This is pretty different. I guess yeah, we did get events, of course. Or did we? Nothing was printed though. All of this stuff. It's still incredibly strange that no debug output is being printed. It just hangs here, and this thread has not printed any debug output. Completely non-understandable. Can I repeat this? Because I think at this point, I think the not getting debug output is killing me, because I need debug output to fix all the bugs. I've been working on that the whole evening already. So let's reproduce everything. Quit. Yes. Rerun. Not from here. That from here. Let's ignore this one. It's annoying. Although I don't think it wrote anything. Even now already not. Gee, there's not even a finished. It's like the output O stream went bad or something. real OS is that? What is that? How can I read this, man? I only see good bit, good bit. Set print static off. Let's print on less. Still a lot. This is a F stream. And it seems to be in good order, I would say. Yeah, can I also print if we are turned on or off? That is always a problem. Maybe we should add support for that. Can just print if the debug object is on or off. Anyway, next. We have an input event. There's deep output. It definitely should print something. Really? Maybe they just typed the whole namespace wrong to begin with. Step. God, this is how we get the thread specific thread specific data. Yep. Next. Print instance. You can see the off array has a -1, which means that it is on. Yes, so it is on. Likewise, the flush array has a 0. What? Why? So flushing got reset again. And that would be the reason, of course, that it doesn't work. Well, that we don't see any debug output. So if I set this to 1, then maybe it works, and then that is indeed the problem. So let's set it to 1. Instance flush array 0. Set that to 1. Now it is 1. If then I continue, Flush array noise is 1. I'm going to do next. Did that print? Yep. I think it printed. New events. New events equal in. Is that not what we just did? Yeah. So the problem is the flushing is off again. Very good. We made progress again. So when, where, and why did that happen? This is stack, but it's, yeah, it's on this bloody stack, man. It is weird. Get specific. Thread get specific. What is this? What is it? What is it? What is it? What is it? Maybe it returns something temporary. Maybe it returns this. Okay. Quit. So already doing it. It's already 0 here. How about that? Oh, I think I found that one before. Yeah, I remember now. I said another bug was that the flush array should be copied from the thread that starts this thread. It's for thread specific, and this is not the main thread. So we switch to the main thread, and I just print this output here. Oh, I don't have std key. Oh, that's 0. Okay. Thread 1, print thread specific 0. Totally works. You print the contents of something that we cast to that, being this address. No TSD ST. Pretty annoying. I think it's probably this thing here. Totally. Dang. No type private. It's so bloody worthless, this debugger. I am Krishna Singh. On top of all the misery of this difficult bug, the debugger doesn't even do its work correctly. I want to know the value of this thing here in this struct. So I can do thread 2. Which thread was this? Thread 2. You can print instance here. We can print the pointer to instance do flush array 0. And then we can print the difference between the two. And that is an offset of 160. So they switch to thread 1. And then we print the contents of the integer pointer at this value plus 160 because I want it. I just want it. And it is a 1. That's what I mean. Well, okay, so another step has been made. It is thread specific data, and the new threads do not copy the value of, well, the parent thread, whatever, for the new debug object flush array. Probably should. Looks like that would be a good idea, yeah. Yeah, you're gonna say hi and then I log off, or no? I'm just kidding. Or you are just saying hi and then log off. I should go to bed, so either way, I think I'm just gonna stop. I have this inside here now, and tomorrow is another day to fix that. Copying this so that yeah, let's quit. Yeah, okay. I should go to bed, which means I'm gonna play a game of chess before I go to bed. You see, ChatGPT is very handy. I typed all of this, and then before I hit enter, I understood what the problem was. It's a rubber duck. Who needs to hit enter? Let's play chess. Oh, talking about chess, I played an external game today and I lost. Yeah, don't want to look at it. I think the reason I lost was because my opponent was playing so fast. What is this? We had 1.5 hours, 1.5 hour per person, plus 15 seconds per move. So it's a really long game. And he was playing like it was a rapid. Well, even faster than a rapid almost. Near instant all the time. And not just making a fast, relaxed move. No, he was speed moving it, like to pick up the piece and fraction of a second. Very annoying. Why is he pushing this? And do I care? I can go here. He will take here probably. I take there. Push this. I go back. How does that help me? We push this immediately and I have to go there. That would be horrible. No, I just take here then. Or take it first here. No, I cannot do that. Okay, I go here. He takes it. I take here. Take. That is true. It should work, I think. Oh no, let's just do it. I can even go here now with the queen. Seems kind of fun because if now he does this, I just take the knight and he resigns, kind of, right? Am I missing something? Is this resignable? Yeah, I don't know. I don't know. He's going here and then I don't have that. Oh, this is still attacked. That's why it wasn't possible. Fuck. Okay, this is not good. Now 2 pieces are being attacked. But I'm almost giving mates. So maybe. I need this square. Not gonna work, not gonna happen. But I can go here, and then he takes my rook. And I take the knight, takes, oh, it's a defended, oh, that's nice. Okay, I'm gonna do this. He takes my rook. And then I take here, defend the knight. I take this rook and threaten something, maybe. Not sure if I'm threatening something. This is a threat. No, the queen is defending that point. Check here. Threaten check and then take the rook. But no, not anymore. Well, I can take here. He takes and then check, goes there and take the rook, and then he takes there. My queen is here. I can just put my thing in front of it. He's attacking my knight. It's kind of annoying. What I also could do is first give check, and then he goes there, and he's attacking my knight horribly, and attacking my queen. And then I take with check, and then he could, if he then takes it, then you have the same situation more or less. Check, check, take, and that is here, which is the same as take, check, because it's more forcing actually. I think it's more forcing to do this and then check again. But the king can also go here. So he just does not take my knight. Oh, that's problematic. That is seriously problematic. Yeah, just take here. Makes sense, I think. So now I'm 2 points down, lose that one, so then we're equal again. But I would rather castle. So if now I castle, then I'm threatening to win the rook, and he could just develop the knight, and nothing happens there. I don't have an attack left. I cannot get this square. Okay, let's take the rook. And then he's gonna take there, of course, and then I do this, and then I can castle. Oh, I'm threatening to pick up another rook. Ha, that's actually, I completely missed it. I completely missed this. This is wonderful, good. I cannot move the knight, and I'm threatening to take this pawn, or even if he moves the pawn. So I'm winning like crazy here. Wow. Well played, Carlo. Well, clearly I had not seen this. Yeah, well, unfortunately. Very unfortunate. Okay, well, yeah, I can take that, I don't care. I can do this, and then I still have that threat. He can still not defend it. I can push this pawn. If I do this, I just give check again. That's not helping. If I castle, he could push this pawn. I just take here first then. And then I can castle, because there is no way he can defend this rook. Rook cannot go. There's nothing that he can use to defend it. So you can safely castle. And next move I will take the rook. Or he resigns and win the game already. Sicilian. Okay, yeah. Go here, he just takes. Yes, check, it's not good. Let's play this. Now I can go here, because no. Well, this would be way more active. I wanted to do this and then force a double pawn, but if I do that, he gives check first. Do that first then. Now I'm threatening at least to win a tempo. Go here, queen has to go back. Yeah, like that. I can go here and then make a double pawn there. He makes a double pawn as well. I don't care. Yeah. Guess whose bishop is bad? My bishop. Everything is on black. Exchange, no, I can, yeah, I don't have the exchange right now. Can go here. He's threatening to take this pawn, so not any longer. That was expected. Now I can push this pawn, and if he takes, I have a horrible attack here. They give up attack. Well, if he takes himself, I'm kind of losing a tempo, I think. Maybe we should just do it now, but then the queen can be put there a little bit too easy. Oh, oops! I gave away a pawn there. I give away more than a pawn. Oh shit! Oh shit! That was bad. Oh, wait a minute. What to do now? Well, the thing is, if he takes, it's pinned. So I could attack it again after that. I put my rook here. No, my job moved here. He can give check. That doesn't work. Here, still check. Does also not work. I think I have to attack like crazy. Attack. Oh bloody hell! I'm thinking. Oh no, he can still not go back because I take it. It's pretty nice. It's pretty nice. And you can attack this pawn though. I want to go here and then give mate. Oh, as soon as I go here, he could theoretically go there. I take a queen. He takes my queen. It's not working. But Yeah, no, it's not working. No, you can just go here with the queen. You cannot take it to go there. Oh, he's going there. I think that I'm definitely a threat to win this bishop here. Very, very much. Very much so. I'm trying to win actually. It was my move. I can just go here. Threaten mate in 2 places, which is undefendable. So there is only one way to stop this. And that is put the queen here. And then just take the bishop. Then I have a bishop. But I was already pieced down. So not actually not the best thing maybe. Yeah, he's doing that. Now yeah, let's win back the bishop before that is too late. Now I can rotate this maybe. I can push the pawn. No, I cannot. So I put the rook here and then the queen there. And then the queen has to go there to defend that. Oh, now he can do that. Yeah, that's true. No, that is possible. Do you think I can let him take my rook? I mean, check. If he goes away, check again, check and mate. If he takes back, also check and mate, right? Let's see. Take here, I'll check and mate. Yeah, he cannot take there. So let's make a mistake. I'm gonna go here just to see if he will take the rook now. Probably better I should have taken this pawn, actually. No, okay. How about now? If I take it now, it's the same thing. He can still not take here. I take here, and then he takes my rook, and then I take here a check. He takes like that, and I give check here. Goes there, check, 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 check. That should go mate, come on. Can I safely take this? Of course I can. Just take my rook, man. He does not want my rook. Yeah, where do I want to go then? Just go back or here. It's kind of no longer an attack. I'm running out of time. Oh shit. That was an important pawn for my attack. Yeah, it's nothing. We totally lost this. Not bad. Not bad at all. Could not defend it. Dang, he sees it. Okay, I'll take 2 rooks. Must be good as well. Or maybe it isn't. Draw. Lame. Okay, no it's down. No, nothing left. I can just take the pawn actually. Nothing left. Yeah. Okay, let's go to bed.